Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about understanding the discriminant.
Minute Math, when you need help you use Minute Math.
We're given this problem right here, 6p squared minus 2p minus 3 equals 0, and we need to find the discriminant. We use our formula right there, so we need to plug in our b, a, and c values. So we use a formula, our discriminant is equal to b squared, so negative 2 squared, minus 4 times the a value, which is 6, and our c value, which is negative 3. And now we have to simplify this. Well, negative 2 squared is a positive 4, and 4 times 6 times 3 is a 72. The two negatives make a positive, so we have plus a 72 here. Then we add them together. D equals 4 plus 72, and that is a 76. And so our discriminant here is 76. We're given this problem right here. Negative 2x squared minus x minus 1 equals 0, and we need to find the discriminant. Well, I use my formula here. The discriminant is equal to our b value, which is negative 1, squared, minus 4 times our a value, negative 2, times our c value here, a negative 1. And now we just have to solve. Well, negative 1 squared is positive 1. And then 4 times 2 times 1 is 8. And then we have 3 negatives. Negative times a negative times a negative is a negative. So we have a negative 8 here. Well then, 1 minus 8 is a negative 7. And so our discriminant here is negative 7. We're given this problem right here. Negative 4m squared minus 4m plus 5 equals 0. And we need to find the discriminant. Well, first thing here is I've used my formula since it's equal to 0. So D is equal to, well, our B value, which is a negative 4 right here, squared, minus 4 times the A value, which is negative 4, times our C value, which is 5. And now we have to solve. Negative 4 squared is a positive 16. And then 4 times 4 times 5 is 80. And we have a negative times a negative, which makes it a positive. So now we have 16 plus 80. 16 plus 80 is a 96. And so our discriminant here is 96. We're given this problem right here. 5b squared plus b minus 2 equals 0, and we need to find the discriminant. Well, we use our formula for the discriminant. Our discriminant is equal to our b value here, in this case it's 1, squared minus 4 times our a value, which is 5, times our c value, which is negative 2. And now we have to solve this. Well, luckily 1 squared is just 1. 4 times 5 times 2 is a 40. And then a negative, and the negative multiplied is a positive. So now we have 1 plus 40. Well, 1 plus 40 is 41. Hopefully you got that. And so our discriminant here is 41. We're given this problem right here. R squared plus 5r plus 2 equals 0, and we need to find the discriminant. Well, we use our formula here. Our discriminant is equal to our b value, in this case 5, squared, minus 4 times our a value, which is 1, times our c value, which is 2. And now we're solving. 5 squared is a 25, and then 4 times 2 times 1, don't forget that, is an 8, and we still have the subtraction going on there. Our discriminant is equal now to 25 minus 8, which is a 17, and so our discriminant is equal to 17. We're given this problem right here, 2p squared plus 5p minus 4 equals 0, and we need to find the discriminant. Well, we use our formula here. Our discriminant is equal to our b value, in this case it's 5, squared, minus 4 times our a value, which is 2, times our c value, negative 4. And now we need to solve. 5 squared is, well, 25. 4 times 2 times 4 is a 32. 2 negatives being multiplied makes that a positive. So we have 25 plus 32. We add them together and we get a 57. And so our discriminant here is 57. We're given this problem right here. 9n squared minus 3n minus 8 equals a negative 10. And we need to find the discriminant. Well, first thing is I need to get this equal to 0. So I'm going to add a 10 to both sides here. And I'm left with a 9n squared minus 3n plus 2 equals 0. Now we have our equation equal to 0. We use a formula. Our discriminant here is equal to our b value, in this case is negative 3 squared minus 4 times our a value, which is 9, times our c value, which is 2. And now what we want to do is we'll simplify this, or solve it really. Negative 3 squared is a positive 9. And 4 times 9 times 2 is a 72. And we keep the minus sign there. 9 minus 72 is, well, a negative 63. So what does this tell us? Our discriminant here is negative 63. And since that discriminant is less than 0, we have two imaginary solutions. And that is our final answer. We're given this problem right here. Negative 2x squared minus 8x minus 14 equals a negative 6. And we need to find the discriminant. The main thing here is I want to get my equation equal to 0. So I'm going to add a 6 to both sides here. And I have a negative 2x squared minus 8x. And negative 14 plus 6 is a negative 8. And that's equal to 0. Now I'm going to use my formula. Our discriminant is equal to our b value, which is negative 8 right here, squared minus 4 times a, which is negative 2, times c, which is negative 8. Now from here we're solving. Negative 8 squared is a positive 64, and 4 times 2 times 8 is also 64. Then we have a negative times a negative times a negative, which is a negative. So we have 64 minus 64, and 64 minus 64 is 0. What does that tell us? If our discriminant is equal to 0, which it does here, we have one real solution. And that is our final answer. We're given this problem right here. 9m squared plus 6m plus 6 equals 5. And we need to, well, find the discriminant. First thing I want to do is subtract a 5 to both sides. 9m squared plus 6m, and 6 minus 5 is a 1. And that's equal to 0. Now that it's equal to 0, we can use our formula. Our discriminant is equal to our b value, which is 6 here, squared, minus 4 times a, which is 9, times c, which is 1. And now we want to, well, solve this. 6 squared is a 36, and 4 times 9 times 1 is also a 36, and we're subtracting the 2. Well, 36 minus 36 is 0. So our discriminant here is equal to 0, and what does that tell us? Well, if our discriminant is equal to 0, we have only one real solution, and that is our final answer. We're given this problem right here. 4a squared equals 8a minus 4, and we need to find the discriminant. First thing is I want to get everything equal to 0. So I have a 4a squared on the left-hand side. I'm going to subtract an 8a to both sides, add a 4, and then that makes my equation equal to 0. Now that it's equal to 0, we can use our formula. Our discriminant is equal to our b value, negative 8, squared minus 4 times our a value, which is also 4, times our c value, which again is 4. And now we want to solve. Well, negative 8 squared is a positive 64. 4 times 4 times 4 is also 64. We subtract the 2 still. So now we have 64 minus 64, which is a 0. So our discriminant here is equal to 0, and what does that tell us? Well, that tells us that we have one real solution, and that is our final answer. We're given this problem right here, negative 9b squared equals a negative 8b plus 8, and we need to find the discriminant. First step, bring everything to the left-hand side so it's equal to 0. Negative 9b squared is already there, but we add an 8b to both sides, then we subtract an 8 to both sides, and that gets it equal to 0. Now we can use our formula for the discriminant. Our discriminant is equal to our b value, which is a positive 8, squared, minus 4 times our a value here, negative 9, times our c value, which is also a negative 8. We now need to solve this. Well, 8 squared is 64, a good old number here. 4 times 9 times 8 is a 288. Negative times a negative times a negative is also a negative, so we subtract the 2. Now 64 minus 288 is a negative 224. So our discriminant here is equal to a negative 224. So what does that tell us? Well, it tells us, since it's less than 0, that we have two imaginary solutions. And that is our final answer. We're given this problem right here, negative x squared minus 9 equals 6x, and we need to find the discriminant. First thing is we want this equation equal to 0. So I'm going to subtract the 6x to both sides, and we have a negative x squared minus 6x now, minus 9 equals 0. We now use our formula. Our discriminant here is equal to our b value, negative 6, squared, minus 4 times our a value, negative 1, times our c value, which is a negative 9. And now what we want to do is, well, solve this. Negative 6 squared is a positive 36, and 4 times 1 times 9 is also a 36. But we have a negative times a negative times a negative, which is a negative. 36 minus 36 is 0. That's a 0 there. So what does that tell us? Well, our discriminant is equal to 0, so that means we have one real solution, and that is our final answer. We're given this problem right here, negative 4r squared minus 4r equals 6, and we need to find the discriminant. First thing I want to do is, well, bring the 6 to the left-hand side. So we have 4r squared minus 4r, and by subtracting a 6, we have a minus 6 now, and it's equal to 0. Now that our quadratic is equal to 0, we can use our formula. Our discriminant is equal to our b value, negative 4, squared minus 4 times our a value, negative 4 times our c value, negative 6. Then from here, we want to, well, solve. Negative 4 squared is a positive 16. 4 times 4 times 6 is a 96. We have a negative times a negative times a negative, which is also a negative. 16 minus 96 is a negative 80. So our discriminant here is equal to negative 80, and what does that tell us? Well, it's less than 0, right? So since that happens, we have two imaginary solutions, and that is our final answer. We're given this problem right here, 8b squared minus 6b plus 3 equals a 5b squared, and we want to find the discriminant. First thing is, I want to get this equation equal to 0. So I'm going to subtract a 5b squared to both sides. 8b squared minus 5b squared is a 3b squared. Minus 6b and plus a 3 come down, but we're equal to 0 now. So now we can use our formula for the discriminant. Our discriminant is equal to our b value, which is negative 6, squared, minus 4 times our a value, which is 3, and times our c value, which is also 3. So let's solve. Negative 6 squared is a positive 36. 4 times 3 times 3 is also a 36. And we're still subtracting the 2. Well, 36 minus 36 is 0. So what does that tell us? Well, our discriminant is equal to 0, so we look here and we say, oh, it is one real solution. And that is our final answer. We're given this problem right here, negative 6x squared minus 6 equals a negative 7x minus 9, and we need to find the discriminant. Let's get everything equal to 0. So a negative 6x squared stays here. I add a 7x to both sides, and then I add a 9 to both sides. And so negative 6 plus 9 comes out to be a 3, and it's equal to 0. So now I use my formula for the discriminant. The discriminant is equal to our b value, which is 7 squared, minus 4 times our a value, which is negative 6, times our c value, which is 3. Well, 7 squared is a 49, and then 4 times 6 times 3 is a 72, and a negative times a negative is a positive. We add these two together, and 49 plus 72 is 121. So our discriminant is 121, meaning it's greater than 0. So we know we have two solutions here, but are they rational or irrational? And that question comes down to what's the square root of 121? Well, the square root of 121 is equal to 11. 11 here, well, it goes in nice and evenly. It's a rational number. So that tells us that we, well, have two rational solutions. And so we have two rational solutions. And that is our final answer. We're given this problem right here, 4k squared plus 5k plus 4 equals a negative 3k, and we need to find the discriminant. Well, first thing is I want to get everything equal to 0. So I'm going to add a 3k to both sides. 4k squared is 4k squared plus 5k plus 3k is 8k, plus 4 is equal to 0. Well, now we have our equation equal to 0. We can use a formula. Our discriminant is equal to 8, or b value, 8 squared, minus 4 times our a value, which is also 4, times our c value, which is also 4. We solve this. 8 squared is a 64, and 4 times 4 times 4 is also 64. We're still subtracting here, and so we have d equals, well, 64 minus 64 is 0. So what does that tell us? If our discriminant is 0, then we have, well, one rational solution. And that is our final answer. We're given this problem right here, negative 7n squared plus 16n equals 8n, and we need to find the discriminant. Well, first thing is I want this equal to 0. So I'm going to subtract an 8n, not just 8, but 8n, to both sides. Negative 7n squared, and then 16n minus 8n, I'm struggling with that, is a positive 8n, and that's equal to 0. So now we can use our formula for the discriminant. Our discriminant is equal to our b value here, which is 8, squared minus 4 times our a value, negative 7, times our c value, which isn't written, but it's 0. So what does this tell us here? Well, let's simplify it. 8 squared is a 64, and 4 times negative 7 times 0 is also 0. Well, two negatives make it a positive, but it's just 0. So 64 plus 0 is 64. So our discriminant is 64, and so what does that tell us here now? Well, it's greater than 0, so we have two solutions, okay? Are they rational or irrational? Well, square root of 64 is equal to 8, which is a rational number. So we have two rational solutions, and that is our final answer. We're given this problem right here, 2x squared equals 10x plus 5, and we need to find the discriminant. Well, first thing I want to do is, well, subtract a 10x and a 5 to both sides to get this equation equal to 0. So we have 2x squared here, and then subtract a 10x, and subtract a 5, and now it's equal to 0. Well, now we can use our formula for the discriminant. Our discriminant is equal to our b value, which is negative 10, squared, minus 4 times our a value, which is 2, times our c value, which is negative 5. Now from here, we can, well, simplify this, or really solve it. Negative 10 squared is 100. And 4 times 2 times 5 is a 40. And negative times a negative is a positive. So our discriminant here is equal to 100 plus 40, which is 140. Great. So our discriminant is clearly greater than 0. So we have two solutions that are going to be real. Are they rational or irrational? Well, the square root of 140 doesn't go in evenly. It's not a rational number. It's irrational. And so by that, or because of that, we can say we have two irrational solutions. And that is our final answer. We're given this problem right here. Negative 10n squared minus 3n minus 9 equals a negative 2n. And we need to find the discriminant. Well, first thing is I want to get this equation equal to 0. So I'm going to add a 2n to both sides. Negative 10n squared comes down. Negative 3n plus 2n is a negative 1n. Minus 9 is now equal to 0. So now, since it's equal to 0, we can use our formula. Our discriminant here is equal to our b value, negative 1 squared, minus 4 times our a value, which is negative 10, times our c value, which is negative 9. Then from here, we want to, well, solve this. Negative 1 squared is a positive 1. 4 times 10 times 9 is 360. And a negative times a negative times a negative is a positive. So, oh sorry, it's a negative. Oh, almost messed up there. Two negatives make a positive, but the third negative made it negative. 1 plus a negative 360 is a negative 359. If you caught that mistake, let me know in the comment section below. So our discriminant here is equal to negative 359. And what does that tell us? Well, it's clearly less than 0. That would have been a big mistake, but it's less than 0. So that means we have two imaginary solutions. And that is our final answer. We're given this problem right here. Negative 9r squared minus 8r minus 1 equals r minus r squared minus 9. And we need to find the discriminant. Well, I want to get everything over to the left-hand side, get it equal to 0. So I subtract an r to both sides, I add an r squared to both sides, and I add a 9 to both sides. What does that give me? Well, negative 9r squared plus r squared, and negative 8r squared. Negative 8r minus an r is a negative 9r, and negative 1 plus 9 is a positive 8. And now that's equal to 0. Since our quadratic is now equal to 0, we can use our formula. Our discriminant here is equal to our b value, negative 9 squared, minus 4 times our a value, negative 8, times our c value, which is a positive 8. Now we're solving. Negative 9 squared is a positive 81. And 4 times 8 is 256. Negative times a negative is a positive. We add them together here, and 81 plus 256 is a 337. So our discriminant here is 337, and it's greater than 0. So we have two real solutions, but are they rational or irrational? So we look at the square root of 337. What is that? That is irrational. So since the square root of 337 is irrational, we have two irrational solutions, and that is our final answer. We're given this problem right here. Negative 3p squared plus 10p plus 5 equals a negative 8p squared, and we need to find the discriminant. First thing, we want this equal to 0. So I'm going to add an 8p squared to both sides. Negative 3p squared plus 8p squared is a 5p squared. Plus a 10p comes down, and the 5 comes down, and we're equal to 0. Well, now that our quadratic is equal to 0, we can use our formula. Our discriminant is equal to our b value, which is 10 squared. Then we subtract a 4 times an a value, which is 5, and a c value that's also 5. Now we want to solve this. Discriminant equals 10 squared, which is 100. And 4 times 5 times 5 is also 100. And we're subtracting them. Well, 100 minus 100 is 0. And so our discriminant here is equal to 0. Well, what does that tell us? Since our discriminant is equal to 0, we have one rational solution. And that is our final answer. We're given this problem right here. M squared plus 5m equals 2m squared, and we need to find the discriminant. First thing I need to do is subtract a 2m squared to both sides. We want our equation equal to 0, so that's kind of why we're doing that. M squared minus 2m squared is a negative m squared. Our 5m comes down, and it's equal to 0. So our quadratic is equal to 0, so now we can use our formula. Our discriminant is equal to our b value, which is 5 squared, minus 4a, which is negative 1, coefficient up in front of m squared, times c, which isn't written here, but it's 0. Now we're solving. Well, 5 squared is 25. 4 times 1 times 0 is a 0, and 2 negatives multiplied make it a positive. But it really doesn't matter. 25 plus 0 is 25. So our discriminant is equal to 25 here, and what does that tell us? Well, we know it's greater than 0. So then we have two solutions that are real. The square root of 25 is equal to, well, 5, a rational number. And so that tells us that we have two rational solutions. And that is our final answer. We're given this problem right here. Write a quadratic equation that has two imaginary solutions. We first want to start backwards here. We know two imaginary solutions is when the discriminant is less than 0. So we want to find a discriminant that's less than 0. Well, our equation for the discriminant is b squared minus 4 times a times c, and that has to be less than 0. Well, let's go plug in values for b, a, and c that make this less than 0. Well, we'll start with 1s. 1s are pretty easy. 1 squared minus 4 times a is 1, and times c is also 1. 1 squared is 1, great. And 4 times 1 is 4. 1 minus 4 is a negative 3, and that's less than 0. And so we have a b value of 1, a value of 1, and c of 1. Let's go write a quadratic. Coefficient in front of x squared is that 1, just leave it like that. Plus, same thing with the x to b value, also 1. Our c value is 1, we put a plus 1, and then it's equal to 0. Now this is one quadratic that actually has a discriminant that's, well, less than 0, meaning we have two imaginary solutions, but there are many solutions here. But for this case, our final answer here is x squared plus x plus 1 is equal to 0. We're given this question. In your own words, explain why a quadratic equation can't have one imaginary solution. Now this is a good question, and this actually comes down to, well, let's look at the quadratic formula. X equals the solution, a negative b plus or minus the square root of b squared minus 4ac all over 2a. Hopefully you can find where the discriminant lies, that b squared minus 4ac. They tell us here that if it's equal to 0 inside the square root, we have one rational solution, but if it's less than 0, we have two imaginary solutions. Well, the reason why we can't have one imaginary solution, it always has to be two, is the imaginary solution only occurs when inside the square root is a negative number. Okay? If it's 0 or a positive number, right? If it's 0 here, think about when it's 0. We would have a negative b plus or minus the square root of 0 over, well, 2a then, right? If the inside discriminant was 0. Well, That's going to clearly give us one rational solution because square root of 0 is 0, and plus or minus 0 doesn't change anything. Okay, it's plus 0 minus 0, it's going to be the same value, so we'll have one solution. But if inside that discriminant is a negative, or the discriminant is a negative number, we have negative b plus or minus here, the square root of a discriminant value, and that's going to be a negative, so it's going to be a negative discriminant value over 2a. Whatever that value is, the discriminant, we know it's negative, okay? When we take the square root of that, it's going to be some imaginary number, something in the form of a plus bi. But we're also having to do the plus or minus there. So plus or minus is going to be applied to that, meaning we always will have two solutions, two different ones that are imaginary. And so that is why, in our own words, or my words, but hopefully you learned something, that our quadratic equation can't have one imaginary solution and must always have, if it's imaginary, two imaginary solutions. I hope this video was helpful for you, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math, when you need help you use Minute Math.